Alright, we're going to be talking about, welcome to video number 28, and we're going to be talking about a little bit of collisions, and then also how those collisions can affect velocity. So, yeah, let's get started. Alright. So, if we have two objects, both of mass m, one of them being stationary, the other one with a velocity of v, after the collision, what would be the velocity of the whole system if they stuck together and it was a perfectly inelastic collision? So no noise, nothing. There's also, it's on a frictionless surface, may I add. So there's no no momentum lost from any external forces. So we're actually going to see here, we can use m1 v1, and that has to be equal to m1 plus m2. But since these are the same, we can write it as 2m. But it needs to be equal. So therefore, velocity has to be half. So the velocity was halved as it made a collision here because the force is being used to push this heavier system now, which would have the mass of 2m. So let's try this out on a problem. So here we have a frictionless surface, a box with, we're going to call this A, then a slightly larger box, B, and then lastly, the largest box, box C. This one has a mass of m, 2m, and the last one of 3m. Alright, so all these boxes, both B and C, are stationary. A is moving with a velocity of v. So we want to find what will be the velocity after box A has collided with B and then C. So what is going to be the final velocity? So at the beginning, we just have one box with mass m and velocity v. And then later, we would have a total, the system would weigh, it would be 3 plus 2 plus 1, which would be 6m. Now, to make these equal each other, velocity has to decrease. And since it's a factor of 6, velocity would decrease. Velocity would be, the initial velocity over 6 would be the final velocity. So that would give us answer B.